So this is a block I kept on inclined plane. Okay, let's go for what are the various forces that are acting. Mg sine theta, then normal reaction, then this will be mg cos theta. Here the friction will act in this direction. And what is the state of block? I see that block is at rest. When there's no relative motion between the surfaces, what is the friction that is acting? Should be static or kinetic? Should be static in nature. The friction will be static in nature. I'll write nearby, or let me call static. So what is this friction value? First, what is n minus mg cos theta equal to 0. Then the friction here should be F should be equal to mg sine theta. And the nature of friction is what? Static in nature. I'll vary this angle of inclination. As I vary theta, I'm going to increase the angle of inclination. As I vary this theta, as I increase theta, sine theta will increase. Try to see here. If sine theta increases, then the friction force will also increase. So is there any upper limit? Let mu s and mu k be the quotient of static friction, quotient of kinetic friction. Now, what is the maximum permitted value of the friction? Equal to limiting friction. So as I increase theta, definitely the friction will keep on increase. So what is the maximum permitted value of this friction? Equal to limiting friction. Now, at one specific value of angle of inclination, I'll call that as the angle of repose. I'm giving different symbol. Theta there, it was a phi. So here, what is the theta? Theta equal to phi. So at this specific angle, mg sine theta, the limiting friction is going to act. Mg cos phi. So here, what is the state of block? Block is at rest. Here, I should use word motion impending. Let me put it here. Yesterday, I think I gave this particular meaning of this. Motion impending means the block is about to shift. So what are the values we'll calculate here now? Now this, as we know, this is mu s, mu k. So what are the equations? N minus mg cos phi equal to 0. Then mg sin phi minus fl equal to 0. Mg sin phi fl is equal to mu s n. So mg sin phi n is equal to mg cos phi. So tan phi is equal to, I'll get mu s. So this particular phi, I'll give a name called as angle of repose. So the angle of inclination at which the block will have motion impending, or the block is about to shift, that particular angle of inclination will call angle of repose. So now what is that? Our angle of repose is related to quotient of static friction by this formula. Tan phi is equal to mu s here. So definitely, can you say anything about this theta? This theta, what we have is less than mu s. So why the block is at rest? Because tan theta is less than mu s here. Why the block is about to shift? Because here the tan theta is equal to mu s. So when the block will shift now, when block is about to shift, tan theta equal to mu s. So let's further increase angle. I'm going to increase further angle. I'll make theta greater than phi. So here definitely theta is what? According to this situation, theta less than phi, I'll call it. Now let me take a situation where theta will be greater than phi. Where theta is greater than phi. So what are the forces acting? Mg cos theta, mg cos theta, normal reaction. The friction acting should be kinetic. Why I should bring kinetic here? And it is going to accelerate down. the block is going to accelerate down. So what is the state of block? Block slides down. So what is the condition? Can we write here now something? Here tan theta is greater than mu s. Here what happened? Tan theta was less than mu s. So when, if a block is kept on a rough inclined plane, will it slide or not? Will determine. Will it slide or not? Will determine. It is determined by this particular condition. The relation between tan theta, theta and the mu s, angle of inclination and coefficient of static friction. Now you may find this very difficult. I'll try to explain. Okay, meanwhile you look. I'll bring it. Very simple things which you can, all of you seeing this. So this is the block. This is the block. And this is the inclined plane. The blue color is what? Inclined plane. Okay, got it now? What I'm going to do is like, I'm going to select increase the angle of inclination. So now you see that I'll increase the angle of inclination. So why the book is not sliding? Maybe the tan theta less than mu s, and at one specific angle you see it started sliding. No? So any reason for that? And now you can see all of you, it started sliding. Why do it is sliding? The reason for that is tan theta greater than mu s. These are things you can really work out in your home. It's not that something, these are very big things. Huh? So the blue color, this pad is what? The inclination. This pad is what? Inclined plane. This notebook is what you are seeing is, the spiritual textbook, what you are seeing is the block. I'm going to increase the inclination. So like why it is not sliding, you can see. I made inclination. Then what happens? It starts sliding here. Got this? So now you do best thing, take notebook, eraser you'll be having, no? That eraser you keep on notebook. Then you keep on tell the notebook. Even for certain angle, you see that it is not sliding. Now at one specific angle, it starts sliding here. The reason for that, when tan theta greater than mu s, the block will slide. Tan theta less than mu s will not slide. Means, sir, what about the heavy, like a 1 kg block, 2 kg block? It's independent of mass. Is it you are keeping heavier block, lighter block? That is immaterial. Whether it will slide or not will determine the relation between the angle of inclination and coefficient of static friction. Getting the picture? Whether it slide or not will determine the relation between the theta and mu s, not the mass of the block. Is it 2 kg block or 100 kg block, irrespective of that. How the friction will vary with angle of inclination. I want the graph. The variation of friction let me show that here only in this section. What is the friction? How it varies with angle of inclination. Theta is what? Looking at all the diagrams, we have to calculate this one. So look at the friction. So as theta is 0, this will be 0 value. How theta? First initially it will vary as that of theta, the friction will be static friction. And look at this, the friction varies as a sine function. Then at one particular value, it will become limiting. Then afterwards, it will now look at the kinetic friction. Any expression for kinetic friction? Let me write here, Fk equal to Km and mu k mg cos theta. So look at the kinetic friction. The static friction varies as that of this one. Whereas the kinetic friction varies as a cosine function. So the possible graph, the graph will be, this should be sine function, then afterwards cosine function. Now, why we have to put this gap? Because you know the kinetic friction will be slightly less than the limiting friction, because mu k should be less than mu s, as we know. And what is this angle? Any condition for this angle? Where the nature of friction will change at angle of repose. So shall we put this as phi? And what is that phi? Phi would be equal to tan inverse of mu s. So instead of writing phi, no, let me write tan inverse of mu s here. The angle at which the nature of friction will change. This will be static, this will be kinetic. There's a maximum permitted, you can go for pi by 2. Okay, fine. So this is the the information you can see in many ways. Different things will be there that you have to make observation here. Angle of inclination. Oh. Let me write it fresh. Angle of. I shown the variation of friction. You can also go for the normal contact, the weight, how all the possible graphs will be. Okay, this is about the almost, I think the major theoretical part got over. So you have to just work out the different types of numericals. On inclined plane also I shown that one. So on inclined plane, is it mass matters? Once again, I'm asking whether the block will slide or not. Is it the mass will decide? No, the answer is definitely
your
no.
voice is breaking.
Yes, sir.
Sir, no, sir, your voice is clear.
Sir, it's clear.
Sir, it's clear, sir.
Check. Maybe at your side.
Sir, can you once again explain the graph, sir?
Graph, I'll explain it. Here, the static friction varies as a sine function. So therefore, sine theta. Then, when the nature of friction will change, when the angle of inclination becomes equal to angle of repose. Okay, clear this. So what is that angle of repose? Tan inverse of mu s. Then again, further, when I make theta greater than angle of inclination, the friction will vary as that of cosine function, and it's a kinetic, no? Because the block is sliding down.
Understood.
So you get a cosine function.
Sir?
Yeah.
Sir, small doubt, sir.
Uh.
Sir, at theta is equal to 90 degrees, we have the friction to be 0 now, sir.
Theta equal to 90 degrees is imaginary, no? It become vertical in the block. Not possible.
But friction has to always offer a resistance for relative motion now.
Theta equal 90 degree, don't discuss that case because it will become vertical plane, friction vertical wall. Just in the graph I shown. It's like a limiting case it is. Okay.
Okay, thank you.
Okay, this is about the friction. So let's take the coefficient of friction depends upon the type of surface, doesn't depend on that one. Mu s and mu k are for a given surface, the mu s and mu k are fixed value. We are going to vary the angle of inclination. Don't again put that theta depends on, by varying theta the mu s will change. I think there's a wrong observation. Somebody is asking this one. It's a wrong observation. Theta equal to, sir, like as you vary Angle of inclination mu s will change. No, it's a mathematical equation. Angle of repose equal to that much. You should not interpret here mathematically here.